Let's discuss this question over here. If A and B are square matrices of the same order such that AB is equal to BA. Okay, A and B are commutative in this case. Okay, then prove that by induction A B power n is equal to B power n times A. Very simple. Prove that AB whole power n is equal to A power n times B power n for all n belongs to natural. Okay, let's do that. If A and B are square matrices of the same order such that AB is equal to BA. So given AB equals BA, this is given. Prove by induction. We have to prove by induction. Okay. A B power n is equal to B power n times A. Further, we have to prove something else. We'll talk about that later. But prove this. Proof by induction would imply, proof by induction would imply what? Proof by induction says that what we have over here is A B power n plus is equal to B power n times A. So we'll have to assume a statement Pn. Let Pn is this a statement. What is this? A B power n is equal to B power n times A. Let this is it. For all natural numbers n. For all natural numbers n. Now proving by principle of mathematical induction involves 3 steps. What is the first step? We'll have to check whether P1 is true. The second step says assume Pk is true, and on the basis of that, step 3 says prove that Pk plus 1 is true. Okay, those are the steps that will follow. So step 1 says P1, check P1, P1 should be true. What do we have? A B power 1 is equal to B power 1 times A, and since this is already given, yes, this is true using this statement 1. Right? Using equation 1, this statement is true. That's not an issue, right? P1 is true. Okay. Second step, assume Pk is true. That implies that A B power k is equal to B power k times A. That's what we have, right? Third, step 3. Step 3 says prove that Pk plus 1 is true. Okay. For proving that Pk plus 1 is true, that is A B power k plus 1 is equal to B power k plus 1 times A. And for proving this, we can begin with the LHS first of all, right? We can begin with the LHS. LHS is equal to A B power k times B. Can you observe that? B power k plus 1 can be written as B power k times B. Yeah, in this manner. What else? What else? Once we have this, then this A B power k can be replaced by B power k times A with the help of that condition. Let's call this statement 2, and using 2, this can be done as B power k times A times B. This is using 2. I'll have to use 2. And one more thing that we can use over here is this AB is equal to BA. You can use 1 and we can write B power k times AB as BA. This is using what? Using statement 1. We can observe that, right? What else? This is okay. B power k times B times A, and B power k times B is B power k plus 1 times A. Now B power k plus 1 times A is what we wanted on the RHS. Hence proved Pk plus 1 is 2. Hence proved that Pk plus 1 is 2. Okay. So since step 1, 2 and 3 are done by principle of mathematical induction, we can say Pn is 2. We can say that Pn is true, and that's what we wanted to prove. Pn is true means this is true for n belongs to natural. That's what we have proved over here. Is that all? Yes, that is all. Now we have done this much. Further, prove that this equals this for all n belongs to natural. Can we go ahead and prove that as well? Yes, we can maybe prove that. Let's take a look at the second part after this. Next, what are we supposed to do in this case, right? A B power n is equal to A power n B power n. Now this can also be proved with the help of principle of mathematical induction, but in this case will obviously require something which we have already proved, right? So for proving this, we'll use principle of mathematical induction, the 3 steps, but first let's write the statement Pn. Let Pn is AB whole power n is equal to A power n B power n for all n belongs to natural, right? That's what we have. Then step 1 says P1 should be true. P1 implies P1 says AB power 1 is equal to A power 1 B power 1, which is true. Right? You can observe this is AB, this is also AB. So P1 is true, yes. Principle of mathematical induction step 2 says that assume Pk is true. Assume that Pk is true. What does that mean? Pk is true implies that AB power k is equal to A power k B power k is true. This is assumed. And third, prove Pk plus 1 is true. That is AB power k plus 1 is equal to A power k plus 1 times B power k plus 1. This is important, right? AB power k plus 1 is A power k plus 1 times B power k plus 1. This is true. Let's call this statement 1. Right? And for proving this, we'll begin with LHS. LHS is AB power k times AB. This is what you have, right? AB power k plus 1 can be written as this one, right? What is AB power k equal to? As you can clearly observe, AB power k is equal to A power k, B power k. So this is A power k, B power k. This is A and B. This is the product. Right. And in case of matrix multiplication, what we can do is, since matrix multiplication is associative, we can remove this brackets and we can multiply B power k times A together. This is A power k times B power k times A times B. What is this B power k equal to? Do you remember that we have proved A B power k is equal to B power k times A. This can be done as A B power k. Right? B power k times A is equal to A times B power k times B, which is already present over here, using A B power n is equal to B power n times A, which we have already proved before this. This. What next? A power k times A becomes A power k plus 1. B power k times B becomes B power k plus 1. This is nothing but the RHS of this, right? And this is equal to, since this is equal to RHS, which implies Pk plus 1 is true. By principle of mathematical induction, we can say P1 is true, Pk is true, and whenever Pk is true, Pk plus 1 is true. Therefore, by principle of mathematical induction, we can say by PMI, we can say that Pn is true. What is Pn? Pn is this statement. For n belongs to natural. This is true. Right? That's what you can observe over here. And by principle of mathematical induction, this is true. And therefore, that's the complete proof for this question over here. That's the second part. Further prove that this equals to this. This part we have already solved, and this is the second part of this same question. That is all for this question over here. Right?